Welcome to Chapter 7. We are going to be estimating a population proportion in this video. In this section, we are going to be looking at sample proportions to make an inference about the value of the corresponding population proportion. So here are three main concepts included in this section. We've got a point estimate, we're going to call that p hat, confidence interval, and sample size. Here are some important vocabulary you're going to see throughout this video. Now, one aspect of statistics is estimation, which is the process of estimating the value of a parameter from information obtained from a sample. Remember, a sample is a subset of the population. So the average amount of employees and employers pay for health insurance is this amount per year, or 8% of people surveyed said they ski. All of these examples, the populations are extremely large, so the estimates have to be obtained from a sample. A point estimate is a specific numerical value estimate of a parameter. The best point estimate of the population mean is X bar. That'll be in the next section. But the best point estimate of the population proportion is the sample proportion p hat, and that's what we're going to be talking about today. So suppose a college president wishes to estimate the proportion of students who are teenagers to all students being the population. The president could select a random sample of 100 students and find the proportion to be 32%. From that sample proportion, the president could infer that the proportion of teenage students to all students is 32%. That's a point estimate. We use p hat as the point estimate of the proportion of the population because it's unbiased and consistent. So a Gallup poll was taken in which 1,487 adults were surveyed and 43% of them said that they have a Facebook page. Based on that result, find the best point estimate of the proportion of all adults. So again, if they're asking about all adults, they're asking about the population, and we have a sample of this many. So the best point estimate is p hat, and that in this case is this 43%, which came from the sample. You can read a little bit more here. Go ahead and give this one a try. Press play when you're ready to see the solution. So in this case, we had to actually determine that proportion, so it's 33 out of 362. So now we're going to move into talking about confidence intervals. It's a range of values used to estimate the true value of a population parameter, and it may or may not contain the value of the parameter. It's sometimes abbreviated as CI. So let's look at an example here. In a confidence interval, the parameter is specified as being between two values. A confidence interval for the proportion of teenage students to all students might be between 28 and 35 or 32 plus or minus 0.4. You might see them look in two different ways. So it is the probability that 1 minus alpha, such as 95% or 95 or 0.95, that the confidence interval actually does contain the true population parameter. So let's talk about alpha. We've seen alpha before. So the following table shows the relationship between the confidence level, so the confidence levels over here, and the corresponding values of alpha. These come from subtracting 1 minus the confidence level. When we are looking at our critical values, we are going to again be looking at z sub alpha over 2. So let's just quickly refresh our memory about those. So the critical value is the number on the borderline separating sample statistics that are significantly high or significantly low from those that are not significant. So we're not using the table, we're going to be using spreadsheet technology. And basically we can actually use our Excel spreadsheet to actually find this z-score because we can find out everything to the left over here. So we know that this value here is 1 minus alpha over 2. And we can use that to determine the actual z-score, the z alpha over 2. So let's actually do that. So find the critical value, z sub alpha over 2, corresponding to a 95% confidence level. All right, so first our alpha they give us is 95%. So our alpha is 1 minus 0.95 or 0.05. We want the alpha over 2, so that's going to be 0.025. And then let's draw our curve. So we know that z sub alpha over 2 is over here, and we know that this amount is 0.025. So we know that all of this over here is 1 minus 0.025. And we can actually use our spreadsheet calculator to determine that value. So I'm going to go ahead and open it up. Put this over here. Hopefully you've already made your copy. It's not a binomial distribution. We're talking about the normal distribution, right? And we're finding the z-score. So we're looking for the z-score. And remember that when we're talking about z-scores, the mean is always 0 and the standard deviation is 1. And because I'm typing in not just a value, but an expression, I'm going to put equals 1 minus 0.025. Now, maybe you know what that is, but that's totally fine if you don't. So that's 1.95999. We're going to say that's 1.96. So we get 1.96. That is the critical value for a 95% confidence level. Here's a little more information and a little bit more. So when we're finding the critical z-score for that 95% confidence level, we're using that left area. All right, so we did all that, but if you want to look at it this way, please take your time. So now let's do it for a different confidence level. Let's look at 90%. So step 1, we're going to do alpha, which is 1 minus whatever that confidence level is. So in this case, it's 0.10. So we need alpha over 2, which is half of that, so 0.05. Then we're going to draw our curve. And we know that z sub alpha over 2 is right here. We know that that area is 0.05. So all of this area is 1 minus 0.05. And we can get our z-score if we just come right on back to this table. We know that it's 1 minus 0.05. So we get 1.6448. So we're going to call that 1.645. So go ahead and you try to find the critical values. Press play when you're ready to see the solution. So there are 3 common critical values that I would definitely put on your cheat sheet or commit these to memory, but these are the ones that are the most common. So now let's actually talk about confidence intervals. So we're ready that we've got our critical values ready. Now we know what our p-hats are. And now let's actually build a confidence interval. So these are the requirements for a confidence interval. These will be assumed when we do our problems. And then we have our cheat sheet, excuse me, our flow chart. I'm going to come over here. It looks like this. It's in our Canvas course, and there's a little bit more about it here. But here it is. And so we're talking about proportion, right? So we're going to follow it to this side here. So we're not going to look at anything on this side. And we're talking about one proportion. At this point, we didn't even know that there were 2. So we're going to be looking at this section right here, this confidence interval. That is what we're talking about, just so you can get your head around how to use this flow chart. So let's talk about interpreting a confidence interval when we get the results. We have to be really careful about correctly interpreting it. So we would say for this confidence interval right here, we are 95% confident. They gave us that confidence interval, by the way. We are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the population proportion P. We're not going to say that either of these two. And you can actually fill in the blanks when you are doing a confidence interval. And that is what I suggest you do. They're going to give you the confidence value, and then you're going to fill in the blanks with these values. The next piece is that there is a margin of error for proportions. And a really good way to actually calculate that is if we know the confidence interval, we can subtract the upper bound or the lower bound from p-hat to get the error. So I'll show you an example of that. That's just really helpful to use the confidence interval and the p-hat to get your error. if you want to know how to round, which is really important, you can get like little glitches and errors. We're going to do 3 significant digits. So how do you use a confidence interval? How do you get one? We're going to use our TI-84. And again, I'm just going to refer you back. We have our awesome TI-84 and spreadsheet function calculator here. I like to use the outline. So we are talking about confidence intervals. There are 4 types, if you recall from that flow chart. We're talking about not a mean, that's one mean. We're talking about one proportion. And this will remind you how to use your TI-84. But I've also got it right here. We're going to use the stat feature. So let's bring in my calculator here. We're going to use the stat feature. We're going to go over to tests. We're going to scroll down to one prop z int, not test, but interval. One proportion z interval. And that's where we're going to fill in the pieces. All right, let's get started. We noted that a Gallup poll of 1,487 adults showed that 43% had Facebook pages. So we know that we are talking about a sample of 1,487 and the p-hat is 43. So it wants us to find the margin of error, and it wants us to find the 95% confidence interval. So I like to actually find the confidence interval first and then find the margin of error. So we are going to use our calculator. And again, I'll just show you one more time. Let's get out of here. So we're going to go to stat, test, one prop z int, and it asks for an x, and you might notice, oh my goodness, we don't have an x. So let's go back here and remember that the number of successes x is n times p-hat. So we need to calculate that first. In this case, we're going to multiply 1487 times 0.43, and we're going to get 639. So that's what's going to go in here, 639. The n in this case is 1487, and the confidence interval, the confidence level they gave us is 0.95, and then we're just going to hit calculate. So we actually get our confidence interval to be 0.405 is less than p, which is less than 0.455. And we got all of that from our calculator. Now, what's the margin of error? I like to find the margin of error by taking the upper minus the p-hat. So in this case, my upper is 0.455 minus 0.43. So I get the error, margin of error is 0.025. Now it says write a statement that correctly interprets the confidence interval. I'm just going to use that fill in the blank. We are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the population P. Excuse me, the population P, population proportion P. Excuse me. All right. Based on the results, can we safely conclude that fewer than 50% of adults have Facebook pages? Well, looking here, we can see that this is 46%. So we believe that, that it's happening somewhere less between 40 and 46%. So yeah, we can safely conclude that. Let's look a little bit more about what they're trying to say here and the summary of results here. Let's do one more example together. The drug Eliquis is used to help prevent blood clots in certain patients. In clinical trials among 5,924 patients, 153 developed adverse reactions. Construct a 99% confidence interval for the proportion of adverse reactions. So find the best point estimate. Okay, so we need to find p-hat. So we need to find the proportion. So we know that 153 out of 5,924. So that equals about 0.026, and that is our p-hat. All right, let's carry on. They want us to find the margin of error. I really like to do the confidence interval first. So let's go to our calculator. Stat, tests, one proportion z interval. Our x they actually give us in this case, it's 153. And we know it's out of 5,924. And we need to change this to 0.99. And so we get our confidence interval here is about 0.021 less than p less than 0.031. So to find out our margin of error, I like to do the upper minus the p hat. So in this case, 0.031 minus 0.026. And then it wants us to write a statement to correctly interpret it. And so we're just going to use that fill in the blank. Where did that go? So in this case, we are 99% confident that the interval from 0.021 to 0.031 actually does contain the true value of the population proportion P. Go ahead and give these a try. Press play when you're ready to see the solution. Here's 13 and 15.